This video is a continuation of the functions notebook and will discuss function environment and scoping rules. In R, a function's environment consists of the set of symbols, like variable names, that were present prior to the declaration of that function. Effectively, the function captures these symbols and they are accessible by the function whenever it's called later on. So to see this, let's create a variable a and we're going to assign the value 8. Next, we're going to create a function that takes a single argument b. And then the function is going to output that argument along with the variable a. And since the variable a already existed when we declared the function f, the variable a is part of that function's environment and can be used within the function. So if I were to call the function f and pass, say, the value 6, we see in the output that the value a, which was 8, and 6, the value of the pass argument, both appear. So at this point, we can see that the variable a can be used within the function, even though we didn't explicitly pass it. But what is it that's actually stored in the environment? Is it the symbol or object that refers to the value 8 in this example? Or is it the value itself? So to find out, let's change the value of a and then call f again. This time in the output, we see that the function is using the most recent value of a, followed by 6, which was the value we passed to the function. So the function's environment is truly keeping track of the symbols themselves and not these specific values. This actually gives us a way to modify the behaviors of function without explicitly modifying the arguments passed to the functions, which is quite useful. But at the same time, this can make your code harder to understand and follow, since it may not be clear which variables affect a particular operation without going through every line of code in every function that is involved. Another reason to take care when using variables declared outside of your function is that they might be removed, which will obviously break your function. So if we use the rm function to remove the variable a and then try to call our function again, we see that we get an error stating that the object a cannot be found. So once again, you can take advantage of the symbols included in a function's environment, but care must be taken to ensure that their use is safe and appropriate. In the last example, we simply accessed a variable from the function's environment. But what if we wanted to modify a variable that was created outside of the function? If we were to attempt to do this using the left or right arrow assignment operator, or even the equals operator, we would actually create a local variable with the same name instead of modifying the value of the variable created outside of the function. For example, let's create a variable a again and give it the value 1. And then let us create a function that simply attempts to set the value of this variable a to 42. And now to test this, we're going to call the function f and then print the value of a. And we see that a still has the value 1, which is because we used the standard assignment operator inside of f. Thus, we created a local variable a inside of f and set its value to 42. To modify the variable a outside of f, we actually need to use what's called the super assignment operator, which is the double left arrow or double right arrow. So if we copy this example, all we're going to need to do is modify the assignment operator, and we'll see that the value of the variable a outside of the function is in fact changed by our function f. Now the super assignment operator allows us to modify those variables that were created outside of the local environment. But what happens if we have a variable a inside the function as well? What we're going to do is we're going to copy and paste this one more time. We're then going to create a new local variable a and assign it the value 7 using the single arrow assignment operator. And then after the assignment of a with using the super assignment operator, we're going to then print a, and we want to see what value we get. So in this example, the first assignment using the single left arrow is actually creating a local variable a, as we said, and it assigns the value 7. The second assignment using the super assignment operator still assigns 42 to the outside variable a, not the local one. And we can see this in the output where the print statement from inside f still outputs 7 for the value of a. So using these assignment operators allows us to control whether we assign to local variables or variables that exist outside of the local environment. And I should point out that even with two different assignment operators, you really should avoid duplicating variable names because it makes things confusing. And of course, the variable names should be meaningful, not lazy names like A or F. We know that the set of symbols present when a function is declared make up that function's environment. But how do we know which symbols? The general set of rules used to define which symbols are visible at any point in your code are called scoping rules. To determine if a symbol is visible or present, R will perform a hierarchical search starting with the local environment and working its way up through each enclosing environment until the global environment is reached. The search will stop as soon as a symbol whose name matches is found. If the global environment is reached and still no symbol can be found, then an error is issued. Details on this can be found in section 4.3.4 of the R language definition, linked here in the paragraph. And we're actually going to go through a quick example now. Let's start by declaring our favorite variable a, and we're going to assign the value 5. Just like before, we're going to declare a function f, taking no arguments. And now within the function, we're going to declare another variable with the same name, a. And of course, it's important to realize that because we're using the standard assignment operator, this is not going to be the same a that was declared outside of our function f, meaning that when we set the value 10 here, we're not modifying or replacing the value that was assigned to the variable a outside of the function. So this is not going to be too different from the example we just looked at where we demonstrated the super assignment operator, but we'll be throwing in a little misdirection in the hopes that you will better understand the basic scope rules and function environment. So next, we're going to declare a new function within our function f and call it g. And this function is going to take an argument b, and then it's just simply going to multiply it with a and return the result. And now our function f is going to return the function g. And notice that we're not calling or evaluating g. Instead, we're actually returning the function itself. So when we look at this function, hopefully it's clear that the nested function g is going to be using the symbol a that's declared from within the function f and not the one at the higher level outside of f. But just in case, the function g attempts to use the symbol a, so R is going to look inside the body of g to see if a has been declared, which it is not. It then moves up a level, which is the body of f, and it finds that there is a symbol a. So the variable a within g will actually use this one that's been declared inside of f. If we call the function f and assign its return value, which is the function g, to the variable u will now be a function. And we can call u, right? We can say u with the argument 2. And we see in the output that we get the value 20, which is 2 times 10, where the 2 comes from the argument passed to the function u, and the 10 comes from the value of the symbol a, which was declared inside the function f. So we can see from this that it doesn't matter where g, or u in this case, is called, because when g was declared, the environment is defined by the set of symbols present at that time, and not when it's called later on. And so we can see that it still uses the variable a from inside the function f, and not a from the enclosing environment. And of course, just like before, the value of a here in the outer environment is still 5. It was not modified by our function f or g.